Okay. So hi everybody, Hebrew and English speakers. Okay, so I've received some feedback. I'll start with the general statement. I've received some feedback asking this part of the course to be more lively. So it's really a dilemma. It's really hard to teach coding in a non-technical way because it's a pretty technical thing. So my way to solve this dilemma was to make sure that the tutorials are very hands-on. There was an option to do a remote tutorial, etc. So I decided I want a hands-on tutorial where you come and someone is helping you to code in real time. So I think, tell me if it's, I think that this part is working, right? You're getting help. Are you getting help, the help you need in real time in the tutorial?
Yes.
Yes? Okay. Good. Okay, now for the lecture part, we're a small enough group to make it interactive. So I encourage you to ask questions and stop me during the lecture if you have questions. It's going to be hard to make it more hands-on because that's the lecture part of the tutorial. But we're going to try today a slightly different concept. I'm going to show you some slides, okay, so that maybe we'll give you a better sense of where we are in the lecture and the order of things. And I'm going to try to move from the slides to the PyCharm session. I really believe in this step, in not just showing you slides, because you can find slides on the internet. I personally really believe in this step where you see the person coding and you can follow the coding process and see, okay, she's doing this, why is she doing this, etc. Okay, so I will try to go back and forth from the slides to the PyCharm session, and we'll see if it works this way. Okay, so this is our fifth lecture. We're reaching the middle of the course because we'll be skipping one because of I don't remember fast. So I hope you're keeping on track and with the homework and everything. And I'm going to quickly remind what we did until now. Okay, so until last lectures, we went through the very basics that many of you have probably heard of in other programming languages. So all the different kinds of variables, dictionaries, which I think are a Pythonic concept, right? Cannot think about any. Did you hear about dictionaries before Python? I think it's a Python concept. Okay, we saw list and tuples, the difference between them, Booleans, the if, else, elif statements, of course, the basic loops, the while loop and for loops, and the ways to break and continue within the loops. Okay, and we saw the syntax for building functions in Python. Okay, and in the last lecture, so this I would say is kind of the bread and butter of everybody who's learning a programming language. And in the last lecture, we built upon this like first basic step to give you some specifically Pythonic superpowers. And what I mean, of course, is introducing the modules. Okay, so if you remember, we saw 3 different kinds of modules. Can you remind me?
What do you mean modules?
We saw 3 different ways to import modules. 3 different types of modules that you would import in your everyday routine as a Python programmer. So there was one. Yes.
Also to import the code base.
Okay, so the first option was to import a module that you wrote, okay? And we saw where exactly this module has to sit in your computer so that you can import it, and Python knows how to access it. And I hope that everybody check how to edit the Python path variable. I really hope you did it. Okay, so this was one option. Then the second option was to import modules from the standard library. Okay, and we saw where this standard library sits, and we looked at code inside the standard library. If you remember, there was this date time module and this module that goes to this comics page on the internet and opens it. So this was another option. And the third option was to import library that you would install on the go. And we started talking about one of these library, Numpy. Okay, but the important thing to realize is that this basically was the bread and butter. Now, as you evolve in your Python career, you may install libraries which are very specific to some specific kinds of tasks. If you go to biology, biologists have their own libraries. Okay, the same way we can install Numpy and import it. So every community has their own library. Astrophysicists will see an example of one such library, the one that is used in astrophysics. But in every field, really, people are building their own library. So we're really going from the most general to the more specific. Okay. So Numpy is just one example of this library that adds capabilities to the basic Python you can do in the more general case. So Numpy is one example. Today we're going to add another layer of Numpy because it's really a central library to know how to use. So let's cover this. Okay, so today we'll do a bit more of Numpy, and I will give you two additional libraries. The first one is Scipy. Now, there is a good reason why we're doing this in this order. We saw that Numpy is actually adding an array language to Python. Okay, remember that Numpy is basically adding everything that has to do with arrays. Scipy and Matplotlib, which are the two libraries we're going to talk about today, are building upon Numpy. Okay, so they are using Numpy, and Scipy is allowing you to do all kinds of statistics on Numpy arrays. Okay, there is this object called a Numpy array, which is basically an array. We saw that it's different from a list, remember? So Scipy is giving you the capability to do all kinds of calculations and statistics on Numpy arrays. These are all things that you could code on your own, but the advantage of using a library, do you remember?
You don't have to.
It's optimized.
Well, okay, so you don't have to write it on your own. This is a good point. But also it's optimized, it's been checked, it's been tested by the best programmers, and very often it's written in C, so it's fast. Okay, it's faster than writing it in Python. So Scipy is adding statistics capabilities, and Matplotlib is adding plotting capabilities. Plotting, everybody knows the concept. Drawing a graph. Okay, this is what I mean by plotting. Okay, so and Matplotlib, what it's using for plots is Numpy arrays. Okay, it's receiving Numpy arrays, and it allows you to do fancy plots and graphs with it. Okay. Okay. So let's start with by reminding what we said about Numpy. I really want to add another layer of Numpy because you're gonna have one tutorial on Numpy, but it's really, we could spend 3 lectures on Numpy. Okay, it's a really important library. So we saw that it's doing operations element-wise. You remember, if you have 2 Numpy arrays and you do a plus b, it's going to add every element of the array element-wise. Does everybody understand what I mean by element-wise?
Yes.
Okay, if I do a times b, it's not going to be a matrix multiplication. It's going to be first element of a times first element of b, second element of a times second element of b, etc., etc. Okay. Okay, we saw that it's mostly written in C, so it's fast and you should really use it. And we saw that it has many points in common with Python lists, but it adds these cool Boolean features where you can filter arrays. I will show you an example in a second. And one more thing that you should always have in mind, that what I'm showing you here is just a small bit of all the capabilities of all these libraries. And you should always keep in mind that for this, Google is your best friend. There are tons of resources about each of these libraries online. And the important thing is that you know the very basics so that you can use them for your basic needs. But everything a bit more fancy that you want to use, you would have answers online. Okay, so I'm not going to show you this on PyCharm because this we did last time. Okay, we saw how to build a 1D array. You remember? Okay, and we saw that we can also build a 2D array. Of course, you can build a ND array if you want. It would just be much harder to visualize. And we saw that you can access the shape of these arrays. So the shape is a tuple. Okay, so if I have a 1D array and I do Numpy shape, it would give me the length of this 1D array. And if I take the shape of a 2D Numpy array, it would give me a 2D too long tuple, and I can access the length of the array along each dimension by indexing the tuple. Okay, it's clear? Okay. And this is the Boolean filtering that I mentioned before. If you remember, we said that lists and arrays are different, but they have many points in common. And one thing where they are really different is that Numpy allows you to filter an array with a specific condition. Okay, so for example, here I want the element of A, of the array A, only those which verify this condition. Okay, are you familiar with this sign? Okay, this sign is like writing OR. Okay,
would you just write OR?
Yes, you could write OR, and there is also a sign for AND instead of writing AND. Okay, you know the sign? It's like a yes. So okay, so here I have the condition. I only want the elements of A that are bigger than a certain number or smaller than a certain number. Okay, and I can filter. Is someone asking? No, it's outside. And I can filter the element of this array according to this condition. So this is very useful. You could code it with a list, okay? But it would take you more than 10 times the amount of time, okay, by doing it with the list. And of course, you cannot do 2D lists. So the moment you want to go 2Ds, you need to work with Numpy. Okay, but this is to convince you that even if you're 1D, you should use Numpy for everything that is not a list, because it has to be a list. Okay, sometimes you come across lists because a certain function outputs a list. Okay, but most of the time, if you can choose, you should choose to work with Numpy arrays rather than lists. Okay? כן, תזכיר לי, אני קורא לך. איך?
דביר. בפייתון מצד ימין, כשעשית A random for II, כאילו, למה קראת לזה II פעם?
סתם. הייתי יכולה לקרוא לזה קייק או I.
למה היא צריכה לעשות רנדום נקודה רנדום?
Okay, so this is the random. This is the random library from the standard library. Okay, the random module. Sorry. Okay, it's not. You remember I told you it's always a good idea to write from blah import blah and not import star, so that you know exactly where a specific package came from or function came from. So this random is not the same random as here. It's the random function of a module within Numpy. Okay, it's doing the same. It's producing a 1D array that is 100 elements long and which has random numbers in it. It's doing the same. It's just not the same. So this is using Numpy and this is using the standard library random. You understand?
Yeah, it's just כאילו, נגיד את זה מזה. רצית כאילו...
לא, זה לא תלוי בי. זה לא תלוי בי.
זה הסינטקס כאילו.
יש בתוך Numpy, there is a function called random, and בתוך הפונקציה הזו יש עוד איזושהי פונקציה, יש שם 5,000 פונקציות, אחת שגם קוראים לה. This is how the Numpy programmers have coded it, and it doesn't depend on me or you, but you could also do from Numpy import random, and then you can just call random. Okay?
תוכלי להעלות למודל את המצגת?
Sorry?
תוכלי להעלות...
ברור, כמובן. ברור. Okay, and these two, I'm not opening PyCharm as long as we're repeating things that I've already shown last time, okay? So we mentioned another bunch of good to know features of Numpy. So if you want to produce the identity matrix, okay, there is this function Numpy I, okay, and Numpy ones is filling the matrix as ones, okay, and you should take care of the parentheses here. So Numpy I, you don't have to put 5, 5, and here you have, okay,
this is the diagonal.
This can be confusing. Yes, so this creates a diagonal matrix that is a 5 by 5 one, but you don't have to specify that it's 5 by 5 because all diagonal matrices are square. But you could
a non-square one.
So you could make a non-square matrix full of zeros. You cannot make a non-square diagonal matrix. So this is why it doesn't require you to specify both dimensions. Okay. So these are good to know. They can be useful. Okay, and I also mentioned various ways to initialize an array. So imagine that you want to create an array and to fill it with numbers through your code, but you still want to have it ready in the beginning. Okay, you understand this kind of situation? You want an array and you want to fill it in the future. You don't want it to be filled yet, so you want to initialize it. So there are several ways to do this. You can put zeros in it, okay? But then what could be a disadvantage of doing this? Okay, so this is an important point. If you don't want it to be full with numbers, okay, if you want to put strings in it and you fill it with zeros, maybe Numpy will not accept that you initialize something as a numerical array and then fill it with strings. Maybe, okay, we'll see that it's indeed the case. But there is another reason which is a bit more. Okay, imagine that you want to fill it with numbers that you are not aware of yet, and some of these numbers may be zeros. Okay, so how would you know that the zeros in your array are the zeros that you've put in it or the zeros from the initialization? Okay, it can be confusing. Maybe you will create some zero data just because the way you initialized it and not because they are actual zeros. Okay, so there is another way to initialize an array with the empty function. So we do numpy empty, and we'll see an example of this. And of course, it doesn't have empty numbers because Python doesn't know how to. Okay, it has to put something in it, but it puts some random numbers which are extremely small, and so they are easy to differentiate from zeros. Okay, and we'll see an example. And the cool thing about numpy empty is that it allows you not to commit about the type of things that you will put in your array later. So as Shai? Yeah. As Yair said, you might want to put some strings and numbers and all kind of things. So the D-type option, keywords, okay, allows you to not commit on the kind of things that you will want to fill the array with. So let's show you an example of this. We'll see if it works, the going back and forward. Okay, so and I need to make the font much bigger. Okay, so I'm importing Numpy as Numpy, okay, and zeros. Okay, so this is going to print zeros. Okay, and now what if I make it an empty file, an empty array instead? So you see that it's putting here numbers which are all 10 to the minus something. I see that there are also some negative, but they are easier to differentiate from zeros. Okay. Now let's assume I want to put a string in this file, in this array. Okay, so here it's complaining. It doesn't want us to put a string in this array because it's initialized it as a numbers array. So if I put instead object, it will let me. It will set. So if I specify the D type to be objects, it would put nonce in the array. It will let me put a string here, and it will also let me put a number. Okay, it's put a string and a number. So it's allowed me to do this mixed types things. Okay? Good. So let's go back to where we were. Okay, so we saw an example, and the last thing I want to talk about regarding Numpy is that Numpy allows you, it gives you one way to read tabulated data. And this will happen to you all the time when you're doing research. What's the reason we want to learn Python? It's because we want to do data analysis, right? So we want to be able to read some data from somewhere, from a file, basically a text file. And one way to load data, to read the data, is by using functions from Numpy called gen from text, which I mentioned last time, and I said that I would prepare a small file, text file, to give you an example. So this is the content of the text file I've made, and let's show you how it works. Okay, so I've put the file in the same directory as we are here. Okay, so I'm doing gen from text. Okay, and I now need to add the path. Okay, the path to this file. Let's show you. Okay, this is the file. So you see that here we have commas as delimiters of our columns. Okay, now this is an important thing because gen from text by default, it assumes that there are empty space as delimiters. So if I do this, it will not recognize that I have 3 columns. Okay, so let's give an example. Okay, it actually thinks there is 1 column with 1, 2, 3, 4, 5, 6, 7, 10. Okay, this is the number of lines. Okay, so it's confused. It's not recognizing that I have 3 columns. Okay, so I have to add here delimiter equal commas, and you could put anything here, depends on your file. So let's see. Okay, so this is good. Here, what is A? What kind of object is A?
Array.
Okay, it's a Numpy array. This is the important thing, okay? Numpy gen from text is reading your data and putting it in what? In a Numpy array. So if you want to later manipulate this data, you'd have to play by the rules of Numpy. Okay? Now, if you remember, in our example file, there was a header, right? So let's remove this and see what happens. It's going to complain. No, it's not. Okay, it's not complaining, but it's actually reading the first line as part of the data, and it's not reading it as strings, it's reading it as none. Okay? So if I wanted to skip the first line, I need to tell it skip header. Okay? And now it's working, it's only reading the data. Okay? Now, skip header by default is skipping 1 line. Okay? It's assuming that you have 1 line of header. If I wanted to skip the 5, let's see. If I wanted to skip the first 5 lines, I need to tell it this would work. Okay, it skipped So here, instead of assuming that I have one line of header by default, I told him skip the 5 first line. Okay? And you can also do skip footer. You can also tell it to skip the 5 last line. Okay, but then you see again it's taken the first line as it's assumed it's real data. There is another important keywords here. Okay, if I wanted to skip everything that has this character, okay, and let's assume that I have another comment here. Okay, so I'm telling it everything that has this character is a comment. You should ignore it. Okay, so you see that it's working. It's not complaining. It's not putting nuns. It's not including anything that is with this hashtag as the actual data. And of course, you can define it as anything. Okay, I can define it as a strudel. And how do you say strudel in English? Okay, if I want the header and the comments to have this symbol first, you can do it. You can define anything. Okay? The delimiter is telling me that what separates columns is a comma. It could also be strudels. Okay? As long as you define it, you tell it what to consider separate columns. Okay, and the other important thing here is that you can also tell it what kind of data is in this Numpy. So you saw that by default it's reading our data and it doesn't handle well mixed type, right? When it was trying to read the first line as text, it was putting none in it. Okay, so let's assume that I have a mixed, that I now have a mixed type of data. 3, 4. Okay, I have this string here, and I wanted to be able to read the string. So by default, it will put a none here. You see? So there is an option to specify the type with the dtype keyword. So let's see what happens if I tell it to read everything as string. Okay, so if I do this, it will read hello. Okay, it won't make it a none, but then all of the numbers will also be read as strings, and I don't want it to be the case, right? So sometimes it's worth it. Sometimes you can read everything as strings and then later turn your string into floats. 1 second. But if you put here objects, okay, this will make it accept mixed types, and for some reason it's still reading these as strings.
מעיין, מה זה הבי בשכינה של המחקרים?
Okay, so this is one of the reasons you may want to read everything as strings and then turn your numerical values into strings. That if you read things as objects, it will add this. This is B for bit, okay, and it doesn't mean much. Okay, you can. It's just indicating that Python is reading everything as sort of uniformly as bits as opposed to numbers. And okay, so let's see. Okay, so you may not always want to have to handle this. Okay, so one option is to read everything as strings and then turns your numbers, your string, the strings, the numbers within your string to float. And you cannot do the opposite, because if you read things as floats, the strings will be turned into nonce and then the information will be lost. Okay, you had the question.
How if we
extract only one table from a text. For example, I have a text with multiple tables, with the title table 1, table 2, etc. I just want to take table 2.
So
Can I do this
there are,
like this, or-
there are several options. One option is, what's your name?
Chen.
Chen. So did everybody hear Chen's question? Chen is saying, what if I want to, if I have 3 different tables in my file and I want the second table, okay? So one option is, let's do it, okay? So I have here table 2 and table 2 is this. Okay, so what, okay, you guys try. What would be an easy way to do this?
Header.
Yes, you can tell it skip header equal to 16. Okay, and you can tell it skip the first 16 lines. See that we have 16 lines here?
But if I don't know the precise line.
Right, so if you don't know, then, I mean, at the end, if you don't know how to separate the tables, Python doesn't know. Like, it only knows what to do if you tell it to, okay? So if you know that there is, I don't know, a title
Yes.
table in your file, you can do something and you can ask it print the line of a table.
So read line, read line, read line.
So load everything, okay? Then with this Boolean, actually it's a good exercise. We can give it to you guys as an exercise. With these Boolean filters, you can tell it what is the index of the word table, okay? And it will tell you table is the 10th line, is at the 10th line, okay? And then you can tell it read everything from the 10th line with this skip header option. Sorry?
Can you say that again? How would you get
So there is a Numpy. You would tell Google output index under condition in Numpy, for example, and it will tell you the index of the words table. Okay, this is the lazy way, but you can also use the Boolean. So you can also use this, okay, and write. Let's actually try it. Our file has become a bit complicated, but if you write table 1, 2, if you do this and do a equal table, okay, it will output a Boolean array. Let's see.
table 2?
Equal. Not working. What is it called? Table 2. Where was it? Numpy 2. Ah, no, it's here. Okay, so A equal table 2. Okay. Print it. Okay, so it's returning.
Because of the bit.
Where is the true here?
Because of the bit. The bit.
Not sure that this is the case, but we can try. Okay, good. So you see that here we have a true, okay? And I don't want to go into this now, but you can easily ask Numpy what's the index of true, okay? And then it will tell you how many lines you need to skip before when reading your file. Okay? Good. We may give this as an exercise. מה?
אפשר לחזור על החלק הזה עם ה-false file.
כן. Here, this is what I showed here, the Boolean file. Okay, you can filter a Numpy array according to a condition. This is an example here.
איך אפשר לעשות פה פרינט אם אין סוגריים ואני עושה רווח?
לא, אבל פה זה רק הדוגמה של איך לעשות את זה, אבל הנה, פה עשיתי פרינט של A שווה לטייבל 2, והוא מילא לי את זה בפולסים, מלבד כאן, אוקיי? פה הוא כתב לי במקום הזה זה נכון, אוקיי? אז what I explained לכם is that you can easily find the index of this true, okay? And one way to ask Google about it would be find index of specific element in array, okay? And then it will tell you how many lines to skip before. Can ask how do you read a file from a specific character, okay? So this will tell you how many lines you need to skip.
פה כשהדפסת בעצם איזשהו תנאי, אז קיבלת false וטרו. אבל מקודם כשהדפסת את זה באמת עם תנאי קטן ב-0.6 וגדול, זה הדפיס לך את המספרים.
נכון, כי פה לא
סבבה.
זה A של זה, אוקיי? אז if I do A of this, it will basically print table 2. Okay? That's the reason. Okay, so...
מעיין, הלייב נפל.
הלייב נפל?
בסדר. אני
אני
יודע,
רוצה לגוגל מיץ.
אני עברתי הלאה.
אז איך
בינתיים
עושים?
נפלנו.
Okay. Okay, so we saw this way to load that data. I should say that in 2 lectures you will learn about another way to load data, which is using a relatively new library called Pandas. I don't know if you heard about it, but Panda is making things even more fast, easy. You don't have to deal with these mixed types of variables in your array. It's making your life even easier. So I would say that maybe 10 years ago, Numpy Gen from Text was the preferred way to load data. But in the last 5 years, Pandas is really the best. It may change again in 5 years, but so in 2 lectures, we'll see another way to load data that is, I think, nicer. Okay, so let's continue. Play from current slides. Okay. Okay, so we're done with Numpy, with the basics of Numpy. So as I said, Scipy is letting you do all kind of operation on Numpy arrays. So these are just a few examples of Scipy capabilities, and I should be honest with you.
Numpy in order to use Scipy.
What?
טוב, אז אני צריך שיהיה לי גם את הקודם בשביל לפני זה.
כן, because Scipy is taking as inputs Numpy arrays. Okay, Scipy is built upon Numpy. So these are a few examples of functions in Scipy, but an important point here to realize is that no one knows all the functions in Scipy. I didn't remember all of these before giving this lecture. Okay, it really depends on what you will need on your everyday coding. Okay, so this is just to give you an example. If you want to do an integral, okay, you can do it manually. you've learned how to do an algorithm for integration, I assume, okay, by calculating the area under a curve maybe in an iterative process. So you can write it on your own, but you can also use scipy.integrate that does it in an optimized way. And I would have to read about this for 1 minute to remind myself how to do it, okay? But the point I'm trying to make here is that it's okay, okay? We won't ask you in the exam to do an integration using Scipy just out of nowhere, okay? Everybody has to check how these things work before using them, but this is to give you a partial list of capabilities that Scipy gives you. So you can do a fast Fourier transform in a very efficient way. You can do interpolation. So the example I will show you is about interpolation, but I first want to show you how to plot things so that we can visualize the result of the interpolation. But we will give an example of this one, okay? Okay, and now the next module package I want to tell you about today is Matplotlib. So Matplotlib is adding the same way that Numpy was adding an array language. Matplotlib is building up on Numpy, and it's allowing you to plot Numpy arrays. It's making plotting extremely straightforward. So the way to import Matplotlib, okay, this is a nice example where you will want to use the shortening that we saw last time. You remember that we saw that you can do import Numpy as NP, and someone asked, but why not just write Numpy? And I said that sometimes it's really long, it's really tedious. So this is an example, okay? If every time I want to plot things I need to write matplotlib.pyplot, it's a bit too much to write. So usually you would import this function package as PLT. Okay, but you can import it as cake if you want. And indeed the simplest plot takes 2 lines of code to do. So I'll show you an example in a minute. This is doing the plot. This line is doing the plot. Okay, you see that here, these are actually lists. Okay, but what Matplotlib is doing in the background is turning your list into an Numpy array. But so this is doing the plot of 1, 2, 3 against 4, 5, 6, and then you can either show it. Okay, we will use this, or you can save it to a file. But doing the plot is 1 line. Okay, so I'll show you an example in a minute.
מעיין,
כן.
אז הפונקציה הזאת מקבלת ליסט או נאמפי?
If you give it a list, it will turn it into a Numpy array and then do things. If you give it a Numpy array, it will, okay? But yes, it does accept other iterables. But I'm pretty sure it's transforming it in a Numpy array first.
So plot creates the instructions and then shows it on the screen?
Exactly. And you don't have to show it, you can also just save it. Okay? So before I show you live examples, let's look at a few additional capabilities that you can add to your plot. So the X label and Y label and titles are allowing you, it's really okay, it's allowing you to add a label to the X-axis, a label to the Y-axis, a title. They accept text, we'll see it in a minute, and both the X label and title, except, does anyone has experience in LaTeX? So Yes? No, raise your hand. Who it used later before? So if you want to write Greek characters in your title or math character or anything, you would have to use the LaTeX way to do it. We'll see in a second, but actually in LaTeX to write the Greek character alpha, you would write it this way, okay? And Python knows how to recognize the LaTeX way of writing these things, okay? You just have to add this like R in front of your string. You can also do, okay, let's look at an example and then I'll show you how you can do subplots. Okay. So I'm importing Matplotlib dot pyplot as PLT, and of course I'm importing Numpy as NP. There is also a package called Byram you've been using, okay, which is importing both Numpy and pyplot at the same time. It's also an option. Okay, and let's start with the simplest plot. So PLT plot 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10. Okay, so this is the simplest one. Okay, so you see that the x-axis here is the 1, 2, 3, 4, 5, and here it's plot 6, 7, 8, 9, 10 here, okay? Okay, what happens if you don't give it the same size? What do you think will happen?
Oh, complain. It will tell you.
It will complain. Okay, it will tell you, it will give you an error which is really, really common. Okay, it will give you, and it's nice about this. It's telling you the detail. First dimension is 5 and second dimension is 4. Okay. Okay. So what if I now want to plot it in red? So there is a keyword called color where you can specify the color. Plotting in red. You remember that we saw that you have to put keywords arguments after positional argument. So you can specify red as a positional argument. It wants me to erase this. Okay, so this would work too. And you can also, okay, let's assume that you want to plot it as points instead of lines. Okay, so here it's plotting both lines and points, but if you put, say, only this, I think it would plot only lines. Right. And there is also a more compact way to do this. You can add the color here. Okay, so this would plot let's put it on the same plot. What would happen? I think this won't happen. No, let's it this way. I'm trying to put things on the same plot so that you see the differences. Array. I think this would work. Okay, and let's assume that I want bigger markers. Okay, so someone asked me if it's taking lists or NumPy array. So you see that here, if I had just multiplied by 2, if you multiply a list by 2, it just makes the list twice as long, right? Remember? So I had to turn it into a NumPy array to actually make it a numerical multiplication. So let's now assume I want it to be blue instead. So, I keep forgetting. Okay, now I'm plotting blue points, and if you want green, you would put a G here. Okay, and so the usual colors are R for red, blue for B for blue, G for green, etc. C for cyan, and M for magenta. Okay, you can find this easily online. And you can also add, if you want some fancier colors than this basic one, you can easily do an import color and import a package of fancy colors that would add colorful capabilities to your plotting code. Okay? Okay, so if you want to add a line, there is a keyword called line style. So if you want it to be dashed lines, for example, you would put this symbol, okay? And I think this means that by default, line style is equal to empty, okay? This is why we didn't see a line. And you can, there is also a short version of this. You can put ls equal, and this, and it understands it as line style. Okay. What other keywords? So you can, there is a marker size, I think, keywords. Let's try this. So let's assume that you want to play with the size of the markers. Okay, and what if you want some star markers instead of round ones? So let's make it green, and let's make it larger, and here even larger, and of course it keeps complaining. Okay. There is a nice, so I keep adding things here to this plot, but the important thing is to remember that the basic one is just one line, okay? So there is one that I like, which adds a grid to the plot. It makes it more readable, okay? It's adding this grid. Let's add a title. Do you remember how to do this? Title. So it takes a string with a Greek alpha character. So this, sorry, I keep forgetting this. So now it will complain. No, it's not complaining, but it's printing it in a funny way, and it's complaining too. So in order to make this work, I would add here R and here dollars. Okay, this is the LaTeX way of coding Greek characters, and this is what Python likes and understands. So let's try this. Okay, you see it's working. It's printing a nice alpha. And let's now add labels. Do you remember the?
X label. Y
Okay, it was X label. So X axis, PLT Y label, Y axis. Okay, and it should add. Okay, you see that it's added a label to the x-axis and the y-axis. Everything here is modular. Okay, if you want to change the size of the x label, ask Google, it will tell you how to do this. If you want to make bold titles, to change the font of the titles, all these things are modular. Okay, and there is, so all these things are modular and are not necessary things that you need to have in mind. Okay, it's okay if you don't know how to change the font of your title without asking Google. But these things, the X label, title, these basic things are things that you need to know. Okay, so another basic one to know is the X lim. So if let's assume that you want to plot your data in a limited range along the x-axis. Okay, you only want the data that is between 2 to 4. Okay, so you would put here a list with the limits of your axis. And, okay, so here you know that it's going from 1 to 5. Let's see what happens if I'm adding this x lim. Okay, so it's now going from 2 to 4. It's actually zoomed in. If you only want to zoom, you don't have to put this x lim. You can. Okay, my computer is not reacting to this, but here there is a small zoom sign that you can use if you want to zoom. But if you want to plot your plot to be limited to a certain range, X lim and Y lim are the way to go. Okay.
יכול גם להרחיב את זה מעבר ל-1 עד 5, נגיד מ-1 עד 10.
So let's see. Dvir is asking, what if you go beyond the range of your data? This is a very good question. Let's see what it does. It's fine with it. It would just it accepts it, but it just gives you an empty plot here because there is no data. Okay.
Is there something that automatically fits into data, or that's just the default setting?
The default setting is that it would plot exactly the data. Maybe a bit more on both sides. Let's see what's the default, but I think it's actually showing, yeah, you know, it's adding small buffers here so that the star is not on the limit of the plot, but it's fitting the size of the, it's matching the size of the plot to the range of your the limits of your data.
אם אני לא רוצה להדפיס קווים אפשריים, כמו סינוס או משהו כזה.
So, okay, so let's try and then we'll move on because I want to show you two more things. I want to show you, so let's see. Okay, so this is going to take the sinus of the sine of this. Let's see what we get. Let's make it a bit, well, okay, let's see. Right, so
Multiply element-wise by pi.
no, let's just look at the Okay, so it will still show you. It will still make straight lines between your data points. Okay, but if you add a lot of points here, it will look increasingly. If you make this יותר צפוף,
More
denser, exactly, it will look increasingly as a sine function. Okay, so now there is two more things I want to show you before we give the Scipy example. So, slideshow. Okay, so one thing is how to plot subplots. Okay, so there is a very easy way to plot subplots in Python, in Matplotlib. Okay, so here it actually accepts a number here. You would have to call subplots. It accepts a number. The first number, it's like an array. Okay, the first number is the number of rows that you want. Okay, then the second is the number of columns. Okay, and the last number is the index where you want to put the subplot. So I'll show you an example and it will become clearer. If it lets me. Okay. Okay, so I have an example from here. I have a ready example. Where is it? 1 second. It's not here. I've made an example for this. This is 2D plots. 1 second, I'll find it. Okay, this is the example I wanted to show you. Okay, so what did I do here? I'm producing data. Okay, I just want it to be random. Okay, so these two lines are simply producing data. Okay, between 2 and 10. And then I'm making 2 subplots. Okay, so I want the subplots to be arranged in 2 lines. Okay, and 1 column. Okay, so this 2 here is the number of lines. This one is the number of columns. And this one here, you see the line here, the one here, it's telling me this is the first, this is the index, this is the first of my 2 plots. Okay? Make sense? And the second plot here, it's the same number of lines, obviously, same number of columns, and this is referring to the second plot. Okay? So in the first subplot, okay, this is the syntax it will be using. So it's calling axis 1 as the first of these 2 subplots. Okay, and then it's plotting the data x1, y1 on this first subplot. Okay, it's giving it its own title. Okay, and then the second plot here, I'm plotting this data, and I've chosen not to give it a x and y label. Okay, now one important thing to take care of is that, do you remember how we gave name to the x and y labels before? Was it with set x label?
No.
No, it was x label and y label, right? But this would not work with subplots. Okay, and this is because subplots is a method of it's because of the way that Matplotlib is structured, okay? But to add X and Y labels to a subplot, you have to use a slightly different method. Okay, it's called set X label and not X label. So let's look at this. Of course, it's complaining that we already have. Okay. So it's made two subplots here. And you see that because I only specified a X and Y label for the first subplot, it only puts it here. Okay? But in the very same way, you can specify labels and the titles for the second subplot. Questions about subplots?
את יכולה לחזור על המשמעות של 2-1-1 ו-2-1-2?
כן. 2-1, it's telling me the structure of my entire thing. Okay, so 2-1 po, it's telling me that I have 2 lines, 1 column. I can also put it to 2 lines and 2 columns. Okay, let's look at the result if I do this. Okay, so because I haven't specified, let's add. Okay, it's gonna be clear. 2, 2, 3. So I will add here. Ah, 2 to 4. Actually, this is a good demonstration. Okay, so what happened here? Okay, 2, 2 is the general structure of the entire plot. It's 2 by 2 matrix of plots. Okay, and then here the last number, so it's 1, 2, 3, and 4, is telling me which plot I'm actually meaning. Okay, so this is a 2 by 2, and this is plot number 1, plot number 2, subplot number 3, and number 4. Okay? So this is the last number, is basically indexing the subplots in the entire structure.
למה יש את כל כאילו, כל ה...
למה הם כולם, למה זה עם קיפולים?
כן.
סתם כי אמרתי לו לעשות פה פסים, אבל אם אני עושה פה נקודות, אז זה לא יהיה... אוקיי? אם זה קווים, אז הוא מקשר בין... So Dvir is asking what are these funny folded lines. So if you put lines here, it will connect consecutive data points. Okay? If you put points, you're losing the information about the order of the data points. Okay? It just randomized data. Has no meaning. Okay? Okay, so this was a subplot example. We have 10 minutes left, so I'm going to give you 2 examples of 2D and 3D plotting. Okay? Just as examples of the kind of things that you can do. So it's good to know that the 2D plotting is done with a function called imshow, which I will show you in a second. Are you expected to know all the capabilities of imshow? Unless you're a programmer in a mapping company, you're not, okay? You're expected to know how to ask Google about specific features you will want to use with it, okay? And it's the same for 3D plot. I'm actually going to show you a 3D plot that I had to do for my research very recently, and I had to check, okay, what's the correct syntax to do it. Okay, this is why I emphasized in the beginning that it's a very important capability to develop, the ability to ask things online in the right way, in the way that will give you the correct answer. Okay. It's not always easy. So I'll show you 2 examples. And then in the last 5 minutes, I'll show you an example of the Scipy interpolate function, okay? So this again, the 2D plot, it should be, it's not here. Okay, 2D plotting example. I think I could actually run this. Okay, so I'm going to copy paste this code into our example. Okay, and here I had to produce everything until here is just producing some data. Okay, so it's not the main point of what I want to show you. The main point I want to show you is this. Okay, there is a function called imshow that allows you to plot an array in 2D. Okay, so let's see what kind of, okay, so this is the kind of plots that you can get with this imshow. Now if you just use the default map of colors, okay, it's a slightly different color map. Okay, all of these keywords have documentation. Again, you're not expected to know all these keywords by heart. Okay, but the interesting thing here is that you can tell it the extent of the plot. Okay, you can, here there is a keyword called interpolation, which means that it's doing, do you see that the data here is pretty smooth? Okay, and obviously I didn't give it a smooth map, I gave it an array, but it's doing some smoothing. Okay, so all of these keywords you can read about, but the important thing to remember is that there exists a function called imshow that under Matplotlib that allows you to do beautiful 2D plots. Okay, and with 3D it's the same idea. So I'm going to, this is from I actually copy paste a code that I made recently. Okay, so this is the 3D example. Okay, so here, let's remove all of this. So this is not something we should worry about. This is opening the data file. Okay, so again, in order to show you an example, I need to somehow load some data. So this is loading the data. Okay, and here I'm going to show you two examples. I'm using imshow. This is doing some plot in 2D. Okay, and now then the next example is going to be this I've done already. It's going to do a 3D plot. Okay, and in order to do these 3D plots, it's using a function called plot surface. Okay, so again, you're not expected to know all the things that you should go into this plot surface, but you're supposed to know that there exists a function under Matplotlib called plot imshow or plot surface that allows you to do this kind of thing, so that you can look for the correct thing when you want to do it. Okay, so let's look at the results of this. Obviously, so I need to add okay, let's try again. Okay, so the first plot you see is a 2D plot using imshow. Okay, so where it's doing a color map. I have this data. I want to do a color map of this data. It's doing this color map here. But now I want to plot it in 2D. Okay, I don't want to plot it by color. Okay, I want to actually see how much higher these values are compared with these values. So I've used this option called plot surface, and it's plotting it in 3D in very few lines of codes. Okay? Okay. Now in the last 4 minutes, again, I'm only throwing examples here so that you're aware of the capabilities. Okay? And in the last 4 minutes, I want to show you an example of the interpolate. You remember I told you that Scipy has all these functions, and one of these is interpolate, but I first wanted to show you how to plot so that you can understand how we are visualizing the results of the interpolate package. Okay, so I've imported Matplotlib here, and from Scipy I'm importing interpolate. Okay, this is only to avoid writing scipy.interpolate, but I could do it. Okay, this is basically producing some data. Okay, and this is calling this interpolate function from Scipy. Okay, and it's using a very specific function here called interp1d, so it's doing interpolation in 1D. Okay, and it's creating some new data, which is the interpolated data. You'll see the result in a second. Okay, so let's try to understand what happened. Okay, X and Y are the blue dots here. Okay, X new is just some Numpy array I've defined, and Y new is using this interpolation capability from Scipy. Okay, so interp1d is creating a function that is basically creating a function that is linking the blue dots from the X and Y axis. Okay, and it takes as an argument X new.
Is it always linking it with linear parts, or it does random?
I'll add a legend here. Interpolated data. And here, let's see if it works. Label equal original data. Okay, so this should make it clearer. Plot. Okay, so I started with this original data, the blue one. I've used Scipy interpolate to interpolate between X and Y. Okay, this has produced F, which is a function to which I can now give any data. Okay, and the orange line is the interpolated data.
So you see there is exact correlation.
Yes, it's doing an interpolation. It means that it's learning the underlying link between X and Y in a way that you can add any data and it will know how to invent the Y from the X. Okay, this is the meaning. This is what we mean by interpolation. Maybe I should have started by reminding you what we mean by interpolation, but this is what we're doing here. Okay, we're interpolating between points. And this is what Scipy interpolates that you do. Okay? But the point here, you already see that this is a pretty specific, specialized thing, okay? That Scipy is allowing you to do this very specific task on your data. This is what Scipy does. It adds some data analysis capabilities to your Numpy arrays. Okay?
So is it basically...
I think just I would say we're done. Anyone who wants to stay for more questions is welcome, but if you want to leave, you can.
Is Scifi basically creating graphs of the data?
With Scipy?
Yes.
לא.
Is that the point of the...
אתה יודע מה זה לעשות אינטרפולציה?
אני חושב שלא.
אוקיי, אז הייתי צריכה להתחיל בזה. אינטרפולציה זה, לך יש את הדאטה הכחול. ועכשיו נגיד שאני, אתה רואה שזה ב-0, 1, 2, טטטה, אוקיי? עכשיו, יש פה איזושהי פונקציה. נגיד שאתה רוצה לדעת מה הערך של הפונקציה הזו ב-0.5, שזה פה. ואין לך פה דאטה פה. אז Scipy הוא בעצם לומד מה הקשר בין X ו-Y, בצורה שאם תיתן לו נקודה שלא הייתה בדאטה הראשוני שלך, אז הוא עדיין ידע איפה לשים את זה.
אבל אם אני לא רוצה שזה יהיה ככה כמו, שזה ייראה יותר בעליות וירידות, צריך לתת עוד נתונים.
אני חשבתי שכולכם יודעים מה זה אינטרפולציה, אבל...
טוב, אבל אתה צריך שזה כאילו, בואי, תצטער אותך שזה כאילו מתאים לאקספוננט שכאילו ניסה. וסייפי כאילו, הוא לומד את האקספוננט הזה כאילו לכל...
אתה רואה, הנקודות הכתומות
זה משהו משלים.
זה משהו משלים, בדיוק. אינטרפולציה זה להשלים את הפערים בדאטה.
נראה לי שהבנתי. תודה.
חשבתי שכולכם יודעים מה זה אינטרפולציה, אז בסדר.
אנחנו עדיין, זה תחום של נומרי?
אוקיי.
אז אני שואל.
לא יודעת, מה זה אינטרפולציה?
לא צריך להשתמש בזה.
לא, בכל מקרה אנחנו...
כן. אינטרפולציה זה להשלים את האחורים בדאטה.
אוקיי.
תודה מעיין.
תודה מעיין.
נראה לי שאנחנו נעשה הפסקה אני מבינה את הרצון שלכם לסיים יותר מוקדם, אבל בחצי